Hello everyone, in this lecture today I'm going to talk to you about how to determine empirical formula and also molecular formula of the compounds. Okay, so the rule to determine empirical formula of the compounds is that first we have to determine the number of moles of each element from its mass, and then we have to divide each element's molar mass by the smallest number of molar amount to yield subscript for a tentative empirical formula. And finally, we have to multiply all coefficients by an integer if necessary to ensure that the smallest whole number ratio of subscripts is obtained. Okay, so this is the rule. Okay, and I will explain how to apply this rule to determine the empirical formula. Okay, so now let's take an example of a question. The question is that a sample of the black mineral hematite is an oxide of iron. Okay, is an oxide of iron found in many iron ores. It contains 34.97 gram of iron and 54.03 gram of oxygen. What is the empirical formula of hematite? Okay, so first, to determine the empirical formula, first we need to write what is the atomic weight. Okay, what is the atomic weight of iron? What is the atomic weight of iron? The atomic weight of iron is 55.85. Okay, so 55.85. This is the atomic weight of iron. And what is the atomic weight of oxygen? The atomic weight of oxygen is 16. Okay, so this is 16. Okay, from where these numbers came, guys? If you look in the periodic table, you will know these numbers. Okay, for the atomic weight or atomic mass, 55 and 85 is the atomic mass of iron, and 16 is the atomic mass of oxygen. These either you have to memorize, or these numbers will be given to you in your examination. Okay, fine. So now we know the atomic masses, and we have also been given the weight in grams. Okay, so the iron ores, they contain actually 34.97 gram of iron. Okay, so basically weight in gram. Okay, so weight in gram, yes, weight in gram of iron. Okay, weight in gram of iron is, we have been given 34.97, so 34.97 gram. Okay, so 34.97 gram, whereas weight in gram of oxygen, okay, weight in gram of oxygen, that has been given to us as 15.03 gram. Okay, so 15.03 gram. So then what we can do then, okay, so first we have to derive the number of moles for each element, as it says here, right? So to determine the number of moles of each element, what is the formula to determine the number of moles? Okay, so guys, up to here, this is the information that has been given, or that is what we know. Okay, so now we have to determine the number of moles of iron. Okay, so basically number of moles. Okay, number of moles of iron. So number of moles of iron, it will be, how to determine the number of moles? Number of moles will be weight in gram divided by, okay, so weight in gram. So this is weight in gram divided by the atomic weight or atomic mass. Okay, atomic mass. So basically, what is the weight in gram that has been given? The weight in gram that has been given for iron is 34.97. So we will write 34.97, and this will be divided by the atomic mass. So atomic mass of iron. So this is atomic mass, okay, of iron, and this is atomic mass of oxygen. So atomic mass of iron is 55.85. Because here we are determining the number of moles of iron, so we will take the atomic mass of iron. So it will be 55. Okay, so 55.85. So this will give us, okay, so what will be the value? You can simply put this in the calculator, and then we will get 0.6261, okay, this many moles, okay, of iron, right? This many moles of iron. So now we determine the number of moles of iron. Then we have to determine the number of moles. Okay, so number of moles okay, number of moles of oxygen, okay, of oxygen. So similarly, so weight in gram, what has been given, weight in gram of oxygen is 15.03. so we will write here 15.03, and this will be divided by the atomic weight of oxygen, which is 16. Okay, so when you divide 15.03 by 16, we will get, so let me use the calculator, we will get 0.9394. okay, so we will get 0.9394. so this is the number of moles of oxygen in that particular compound. So now we have divided the number of moles, so we have derived the number of moles. Okay, so we have derived the number of moles. Point number one, number of moles of each element. Yes, number of moles of each element has been derived. The next thing we need to derive is iron to oxygen molar ratio. Okay, so iron to oxygen molar ratio, how we will derive that. Okay, so divide each element's molar amount by the smallest molar amount to yield the subscript. So then next step is this is up to here is the step number one, and for the step number two, okay, look at this guys, this is 0.9394 and this is 0.6261. so which one is the smallest here? Smallest is the moles of iron, whereas moles of oxygen is the largest. So then we will divide both of these number of moles by the smallest one. So what we will get? We will get 0.6261. when we divide this by, we have to divide this by 0.6261. okay, so which is actually 1 mole. okay, 1 mole of iron, right? And then okay, so we determine the, now we will divide this 0.9394 by this number, yeah, for the oxygen. So basically 0.9394, it will be divided by 0.6261, and the value we will obtain is 1.5 mole of oxygen. okay, so what is this is the relative molar ratio. Yeah, these are the relative molar ratio. So I can actually write here relative molar ratio. Okay, molar ratios. How I derive this? Out of these two number of moles, I first checked which one is the smallest, and I found that 0.6261 is the smallest. So then I divided these both the numbers 0.6261 and 0.9394 by the smallest number. So 0.6261, when it is divided by 0.6261, we get 1 mole of iron, and when we divide this 0.9394, this is the number of moles of oxygen, by 0.6261, we get 1.5 mole of oxygen, right? So step number 2 is complete, guys. Now for the step number 3, what we need to do is that for the step number 3, we have to multiply. Okay, so now rule number 3 says multiply all coefficients by an integer if necessary to ensure that the smallest whole number ratio of subscript is obtained, guys. Now look at this, guys. Okay, so this is already an integer, so we don't need to worry. But the thing, if you look at here 1.5, so which is the smallest number that we can use to multiply to get this as a whole number? The answer is 2, guys. When we multiply this by 2, we will get 3. Okay, so basically then what we need to do, we have to multiply these. Okay, so 1 mole, so it will be also multiplied by 2, and this one also will be multiplied by 2. Then what we will get? We will get, okay, 2 moles of iron, and we will get 3 moles of oxygen. So then what will be the empirical formula? So empirical formula, so basically empirical formula, it will be that for iron, okay, how many we have? We have 2, so that means Fe2, and for oxygen we have 3. Okay, so this is how we can derive the empirical formula from the given masses of the atoms. Okay, so okay, now moving to the next question, guys. In this question, what has been given to us? Okay, here we have not been given the grams, but we have been given the percentage. Okay, let's look what is the question. The bacterial fermentation of grain to produce ethanol forms a gas with a percent composition of 27.29% carbon and 72.71% oxygen. What is the empirical formula? Okay, so what is the empirical formula of this gas? Okay, so basically we have to determine the empirical formula of the gas. That gas is composed of carbon and oxygen. So as in the previous case, first, so basically atomic mass, okay, atomic mass of oxygen, okay. So the atomic mass of oxygen is basically, what is the atomic mass of oxygen? Atomic mass of oxygen is 16. Yep, atomic mass of oxygen is 16, whereas atomic mass of carbon, okay, atomic mass of carbon, so atomic mass of carbon is actually 12.01. okay, 12.01. Yep, these are the atomic masses. Yeah, and let's say we write this gram and gram, and these are the atomic masses. And what is the percent? Okay, we have been given percent composition. That means that, okay, in 100 gram of the given compound, yeah, in 100 gram of the given compound, okay, what is the gram of compound? Yes, sorry for the spelling error. What is the gram of carbon? So basically the weight in gram of carbon. So weight in gram of carbon is equal to 27.29%. That means that we will have 27.29 gram in 100 gram of the compound. Whereas weight in gram of oxygen, okay, so weight in gram, okay, so basically the weight in gram, okay, of oxygen. So weight in gram of oxygen is 72.71%. That means we will have 72.71 gram in 100 gram, yeah, in 100 gram of the compound. Yep. So now we have the weight in grams of carbon and oxygen. Now, like in the previous example, so we have to determine the number of moles. So then number of moles, okay, number of moles of, let's say, carbon is weight in gram, that is 27.29 divided by 16, right? So atomic mass of carbon is 16. So what is the answer we get? We get, when we divide 27.29, okay, by 16, then the, sorry, not 16, weight in gram of carbon is 12. Oh, my apologies, okay. So weight in gram of carbon is 12 here. Okay, this will be because this is 12. Yeah. So when we divide 27.29 by 12, we will get 2.272. Okay. So 2.272 moles. Yeah. 2.272 moles of carbon. Okay. So now next, what we need to do? Then we need to determine the number of moles of oxygen. Okay, so number of moles of oxygen, okay, number of moles of oxygen, that will be weight in gram. So weight in gram is 16, yeah, weight in gram is 16, and this will be divided by the atomic mass of oxygen, guys. So what is the atomic mass? Sorry, this is 27, this is the atomic mass, okay, and what is the weight in gram of oxygen? The 16 is the atomic mass, yeah, atomic mass of oxygen is 16. So what is the weight in gram of oxygen? 72.71. So basically 72.71. Okay, this is the weight in gram and this is the atomic mass of oxygen. Yeah. When we divide 72.71 by 16, what we will obtain? We will obtain, the number that we will obtain is 4 point. Okay, so this is 4.544, okay, 4.544 moles. Yeah, this is many moles of oxygen. So now look at these two numbers. Okay, so this is 2.2722 and this is 4.544. So which is the smallest? Smallest is the moles of carbon. So now we have to determine relative molar mass. So relative molar ratios of atom, yeah, ratios. Okay, relative molar ratios of the atoms in the given compound. So what that will be? Okay, so to determine that, we have to first check which one is the smallest number of moles. Smallest number of moles is 2.272 of carbon. Oh yeah, compared to this one, this is 4.54. So then we will divide this number and this number by this 2.272. That means 2.272 divided by 2.272, which will be actually one mole of what? This is carbon. Yep, 1 mole of carbon. And now we have to divide 4.544 divided by 2.272. Actually, this will be equal to what will be the value of this? This will be equal to 2. Okay, so this will be equal to 2 moles of oxygen. Moles of oxygen. Yeah. So then now we have determined the relative molar ratios. Then we can write, so carbon, for carbon we have 1 and for oxygen we have 2. So this is the empirical formula. We can simply write this as CO2. Yeah, so this is the empirical formula, okay, from this given percentage of the atoms. Okay, so this is how we determine the empirical formula from the when we have been given the percent composition of the atoms. Okay, now moving to the final question, guys. This is also very, very important question, and here we are not only determining the empirical formula, but we are actually determining the molecular formula also, sorry for this. So first we have been given percentage of carbon, percentage of hydrogen, and percentage of nitrogen. Yeah, and we have also been given if 40.57 gram of nicotine contains 0.2500 mole of nicotine, what is the molecular formula? Yeah, here in this question we have to determine the molecular formula, not only the empirical formula. Okay, fine. First what we will do, we will determine the number of moles. Yeah, number of moles. Okay, number of moles of carbon. Okay, number of moles of carbon, this will be, okay, 74.02%. that means 74.02 gram in 100 gram of that compound. So weight in gram will be 74.02. and what is the molecular, what is the atomic mass of carbon? We will write. So the atomic mass of the carbon is 12.01. so basically 12.01, and we will get, what will be the value? The value will be 6.1, yeah, 6.163 mole of carbon. Okay, and then we will, what is the another thing that we will determine? Okay, so 8.710% of hydrogen. So basically number of moles. Okay, number of moles of hydrogen. Oh yeah, number of moles of hydrogen, it will be, this weight in gram of hydrogen, that means 8.710. so 8.710 gram. And what is the atomic weight of hydrogen? Okay, so that is what we will determine. So the atomic weight of hydrogen, or atomic mass of hydrogen, is from the periodic table. We know that the value of this is 1.01. Okay, so basically 1.01, and when we divide this number by this, we will get 8.624 moles. Yeah, moles of hydrogen. And finally, what we need to determine, we need to determine number of moles. Okay, number of moles of nitrogen. Yeah, number of moles of nitrogen, that will be equal to weight in gram. So that means 17.27 gram. Okay, divided by the atomic mass of nitrogen from the periodic table, we know is 14.01. When we do this division, the value we will get is 1.2, yeah, 1.233 moles of nitrogen. Okay, so then we have to calculate molar ratios of these elements. Okay, this is another step, is the molar ratios. Yeah, so molar ratios. Okay, molar ratios, okay, of these elements. Yeah, these elements. Okay, so molar ratios of these elements, that means carbon, hydrogen and nitrogen. How we will do? First we will check which is the smallest number. Smallest number is the nitrogen's number of moles. Yeah, 1.233. So then we will divide all these numbers by 1.233. Okay, so what we will get then? We will get 1.233. Okay, so we will get, when we divide this 1.233, okay, about, let's do the division. To do the division, we will just, okay, let's write 1.233, okay, divided by 1.233, and this is equal to actually 1. Okay, so 1.233 divided by 1.233, this is 1 mole of nitrogen. Okay, 1 mole of nitrogen. And so another is this one, 8.624. So then 8.624 divided by 1.233, that will be what that number will be. So that number will be 7 moles. Okay, 7 moles of hydrogen. And finally we will calculate the number of moles of carbon. Okay, so the number of moles of carbon, that will be 6.163. So okay, let me see. Okay, so the 8 point, okay, yeah, this is hydrogen, and 8.624, yep, and then we will do 6.163. So basically 6.163 number of moles of carbon, that will be 6.163. This will be divided by 1.233, and what we will get? We will get this number as 5. Okay, 5 moles. Yep, 5 moles of carbon. Yeah, 5 moles of carbon. So I mean, what we did, guys, here, we just did the division. Yeah, we just divide all these numbers, 6.163, 8.624, and 1.233, all these numbers by the smallest numbers, yeah, to get the molar ratios of these elements. Yeah, so we did this, and so then after, okay, so now we have the molar ratios of all these elements. Yeah, so after molar ratio of, I mean, this number will be like 6.994. Yeah, when we do divide, you will get here 6.994, but I have simply written as 7. Okay, 6.994 is almost equal to 7. Okay, so then 6.994 is, yeah. So now what we can do, we can actually, from this we know the molar ratios. Now we can determine the empirical formula. Okay, empirical formula. Okay, so empirical formula of the given compound, that is actually, what is the empirical formula? The empirical formula simply will be C5, okay, C5, H7, and N. So this is the empirical formula, N1, yeah, or simply N. We can write this as C5, S7, N, yeah. Why C5? Because for carbon we have relative molar, yeah, 5, and for H7 hydrogen 7, and for nitrogen 1. Okay, so this is the empirical formula. Now we have determined the empirical formula. and what we have to determine is we have to determine the molecular formula. Okay, so to determine the molecular formula, first we will calculate empirical formula weight. Okay, so empirical formula weight. Okay, empirical formula weight. Okay, so empirical formula weight, what will be? So C5, that will be actually C5 H7 and 1. Okay, so C carbon is 12.01, so basically 12.01 times 5 plus hydrogen is 1.01 times 7, and nitrogen is 1 times, okay, so what is the atomic mass of nitrogen? 14.01. When we multiply these numbers and add them, so what we will get? We will get the empirical formula as 81.13. okay, so this will be 81.13, guys. Okay, so this is the empirical formula weight, so 81.13. so what has been given to us? We have been given that if 40.07 gram of the nicotine contains 0.25 moles of nicotine. So from this we can also calculate molecular formula weight. So to determine that, what we know, okay, so we know that number of moles, okay, number of moles of the compound, okay, number of moles of compound, let's say compound, that is actually equal to weight in grams, okay, weight in grams upon molecular weight, okay, molecular weight in grams upon molecular weight. So what is the weight in gram? So weight in gram is actually what is given. Weight in gram of the nicotine is 40.57. So we will write 40.57. We don't know what is the molecular weight of nicotine, but we know the number of moles. The number of moles is 0.25. So 0.25. Okay, so from here we will get the molecular weight of nicotine. Okay, so from here we will get the molecular, okay, weight of nicotine actually is equal to molecular weight of nicotine, that will be equal to 162.3 gram. Okay, 162.3. Yeah, 162.3. So this we will get. So this will go here, and this 40.57 divided by 0.25. So we will get 162.3. So now we know the molecular weight. Now we know the empirical formula weight. Yeah. So then what we have to determine is we have to then determine the subscript. Okay, what is the subscript that we will use to multiply this C5, S7 and 9. For this, what we have to do? We have to determine that by molecular formula weight. So what is the molecular formula weight? So molecular formula weight divided by empirical formula, okay, empirical formula weight. Okay, so what is the molecular formula weight? Molecular formula weight we have, okay, so what is the molecular formula weight? We have is 162.3 divided by, what is the empirical formula weight? Empirical formula weight is 81.13. So 81.13, then this will be equal to 2. Okay, so this actually will be equal to 2. So now we have this 2 number. What we have to do then? We have to multiply, yeah, all these elements. Yeah, these all will be multiplied by 2 to get the molecular formula. So then what we will have? So C5 times 2 is 10, C10, and H7 times 2 is 14, so H14, and N2. Yeah. So C10, H14, and N2. So this is the molecular formula. Okay, this is the molecular formula, not empirical formula anymore. So not empirical formula anymore. This is molecular formula of the nicotine. So C10, H14, N2. So how we determine? First, we determine the number of moles of the each atoms, okay, carbon, hydrogen and nitrogen. We just took the percentage in grams, so 74 gram, 8.7 gram and 17 gram, and divide them by the atomic masses of the respective atoms, and we got the number of moles of these atoms present in the nicotine. Yeah, and then we calculate the molar ratios of these elements. How we calculated that? We took the smallest number of moles and use this number to divide all these all the others, yeah, including this one. So 1.23 divided by 1, and 8.624 divided by 1.237, and 6.163 divided by 1.233. So 5 moles of carbon. Actually, this is 4.999 something, and I wrote this as 5. So then, yeah, sorry, this one is 6.99 something. This is exactly 5. And then, so what we did, then we determine empirical formula. This is C5S7 and 1. So this is afterwards molecular formula, and we calculate the empirical formula. Weight, just divide atomic mass times the number of atoms, atomic mass times the number of atoms, and we got 81.13. And finally, okay, what has been given to us, because we need to know the molecular formula weight of nicotine to determine this molecular formula. So to do that, what has been given? We have been given this 40.57 gram of nicotine contains 0.2500 mole of nicotine. So we use that information to calculate the molecular formula weight. So basically, number of moles of the compound or the nicotine is equals to weight in gram of nicotine divided by molecular weight of nicotine. And so number of moles is 0.25, and the weight in gram is 40.57 divided by molecular weight. And so molecular weight of nicotine that we obtained is 162.3. Then we have to now determine which number we should use to multiply this empirical formula. For that, what we did, we divided molecular formula weight divided by empirical formula weight. So molecular formula weight is 162.3, which is divided by 81.13. This is the empirical formula weight, and we got this number as 2. And finally, we multiplied this. This empirical formula. Okay, this one only is the empirical formula by 2, and then C5 times 2 is 10, and C7 times 2 is 14, and 1 times 2 is 2. So this is how we obtained the molecular formula from the percentage of the elements present in the nicotine. I hope this video was helpful, guys. Please subscribe our channel for more contents like this.